For a 100 amps residential sub-panel with a wiring path of more than 100 feet and several 90-degree bends, the best wiring method is to use conduit and individual THHN wires. Conduit provides mechanical protection for the wires. It also makes it easier to pull and replace wires in the future. Conduit helps to prevent moisture and dust from entering the sub-panel. Individual THHN wires are stranded copper wires that are insulated with a heat-resistant material. They are more flexible than solid copper wires and are easier to bend around corners. To install the sub-panel and wiring, follow these steps. Firstly, install the sub-panel in a convenient location. Secondly, cut the conduit to the desired length and bend it around any corners. Thirdly, pull the THHN wires through the conduit. Fourthly, connect the THHN wires to the sub-panel and the main electrical panel. Fifthly, turn on the power and test the sub-panel. Here are some additional tips for wiring a sub-panel. Use a wire size that is appropriate for the amperage of the sub-panel. Use a conduit size that is large enough for the number of wires that you are running. Keep the wires neat and organized. Label the wires so that you can easily identify them in the future. Obtain all necessary permits and inspections. When selecting the right size conduit for your wiring, consider the number and gauge of the conductors you will be running. The National Electrical Code, or NEC, provides tables to help you determine the appropriate conduit size based on conductor fill. Using the correct conduit size ensures proper heat dissipation and prevents damage to the conductors. It is generally recommended to use Schedule 40 PVC conduit for residential applications, as it is durable, cost-effective, and easy to work with. However, in some cases, such as when exposed to direct sunlight or physical damage, rigid metal conduit may be a better option. When pulling wires through conduit, use a wire pulling lubricant to reduce friction and make the process easier. Ensure that the conduit is properly supported to prevent sagging or damage. When making connections in the sub-panel, use appropriately sized connectors and torque them to the manufacturer's specifications. This will ensure a secure and reliable connection. Remember to always de-energize the circuit before working on any electrical components. Verify that the power is off using a non-contact voltage tester. When working with electricity, safety should always be your top priority. Always wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Be aware of your surroundings and avoid distractions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the sub-panel for you. A licensed electrician has the training and experience necessary to safely and properly install the sub-panel and wiring. They can also ensure that the installation meets all applicable codes and regulations. Choosing the right wire size for your 100 amp sub-panel is crucial for safety and performance. The wire size must be adequate to carry the intended load without overheating, which could lead to a fire hazard. In general, for a 100 amp sub-panel, you will need to use copper wire with a minimum size of number 3 American wire gauge or AUG. Aluminum wire requires a larger gauge, typically number 1 AWG, to carry the same current. The NEC provides specific guidelines for wire sizing based on the ampacity of the circuit and the type of insulation. It is important to consult these guidelines to ensure that you are using the correct wire size for your application. Factors such as ambient temperature and the number of current-carrying conductors at a raceway can also affect the ampacity of the wire, so it is important to take these factors into account when selecting the appropriate wire size. When running multiple conductors through a conduit, it is important to consider the derating factors specified in the NEC. Derating factors are used to reduce the allowable ampacity of conductors when they are installed in close proximity to each other, as this can increase the temperature of the conductors and reduce their lifespan. The NEC provides tables that specify the derating factors based on the number of current-carrying conductors in a raceway. It is important to apply these derating factors to ensure that the conductors are not overloaded. When making connections in the sub-panel, use appropriately sized rated connectors. Ensure that the connectors are properly tightened to provide a secure and reliable connection. Loose connections can cause overheating and arcing, which could lead to a fire hazard. Use a torque wrench to tighten the connectors to the manufacturer's specifications. This will ensure that the connections are properly tightened without being over-tightened, which could damage the connectors. Grounding is an essential part of any electrical system, as it provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The grounding system consists of the grounding electrode conductor, the equipment grounding conductor, and the grounded conductor, also known as the neutral. The grounding electrode conductor connects the grounding system to a grounding electrode, such as a ground rod or a metal water pipe. The equipment grounding conductor provides a path for fault current from the metal enclosures of the electrical equipment back to the grounding system. The grounded conductor is connected to the neutral point of the electrical system and provides a return path for current under normal conditions. Ensure that the grounding system is properly installed and connected to all electrical equipment. In addition to the equipment grounding conductor, it is also important to install a ground fault circuit interrupter, or GFCI, in circuits that serve areas where water is present, such as bathrooms, kitchens, and outdoor receptacles. GFCIs are designed to detect small amounts of current leakage to ground and trip the circuit, preventing electrical shock. They are an essential safety device in any home. When installing a sub-panel, it is important to properly bond the neutral and ground in the main panel, but keep them separate in the sub-panel. This is because the neutral conductor carries current under normal conditions, while the ground conductor only carries current during a fault. If the neutral and ground are bonded in the sub-panel, it can create a parallel path for current to flow, which could lead to nuisance tripping of the circuit breaker. The NEC requires that the neutral and ground be kept separate in sub-panels to prevent this. When running conduit, it is important to properly support it to prevent sagging or damage. Use conduit hangers or straps to secure the conduit to the wall or ceiling. Space the supports according to the manufacturer's recommendations. This will ensure that the conduit is properly supported and will not be damaged by physical stress. When bending conduit, use a conduit bender to create smooth, even bends. Avoid kinking or flattening the conduit, as this can reduce its capacity and make it difficult to pull wires through. Follow the manufacturer's instructions for using the conduit bender. When pulling wires through conduit, use a wire pulling lubricant to reduce friction and make the process easier. Apply the lubricant to the wires before inserting them into the conduit. This will help the wires slide through the conduit more easily. Avoid using excessive force when pulling wires, as this can damage the wires or the conduit. If the wires become stuck, try using a fish tape to help pull them through. When making connections in the sub-panel, use a torque wrench to tighten the connectors to the manufacturer's specifications. This will ensure that the connections are properly tightened without being over-tightened, which could damage the connectors. Over-tightening can also damage the wires, so it is important to use the correct torque. After completing the installation of the sub-panel, it is important to test it to ensure that it is working properly. Use a multimeter to check the voltage and current at the sub-panel. Verify that the voltage is within the acceptable range, typically 120 volts or 240 volts depending on the circuit. Check the current to ensure that the sub-panel is not overloaded. If you are not familiar with using a multimeter, it is best to hire a qualified electrician to perform the testing. If you are planning to install the sub-panel yourself, it is important to obtain all necessary permits and inspections. Contact your local building department to find out what permits are required for electrical work in your area. Schedule an inspection with the building department after the installation is complete. This will ensure that the installation meets all applicable codes and regulations. Remember, working with electricity can be dangerous, so it is important to take all necessary precautions. Always energize the circuit before working on any electrical components. Wear appropriate personal protective equipment such as safety glasses and insulated gloves. Be aware of your surroundings and avoid distractions. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the sub-panel for you. When choosing between copper and aluminum wire for your sub-panel, consider the following factors. Copper wire has a higher conductivity than aluminum wire, which means that it can carry more current for a given wire size. Copper wire is also more resistant to corrosion than aluminum wire. However, aluminum wire is lighter and less expensive than copper wire. In general, copper wire is preferred for most residential applications, but aluminum wire may be used in some cases where cost is a major concern. If you are using aluminum wire, be sure to use appropriately rated connectors and antioxidant compound to prevent corrosion. When selecting a circuit breaker for your sub-panel, choose a breaker that is rated for the amperage of the circuit. The breaker should also be rated for the voltage of the circuit, typically 120 volts or 240 volts. Ensure that the breaker is compatible with the sub-panel. Circuit breakers are designed to protect the circuit from overloads and short circuits. They will trip automatically if the current exceeds the rated amperage. It is important to choose the correct size breaker to prevent nuisance tripping. When wiring a 100 amp sub-panel, you will typically need a 4-wire system consisting of 2 hot wires, a neutral wire, and a ground wire. The 2 hot wires are connected to the 2 hot buses in the main panel and provide 240 volts power. The neutral wire is connected to the neutral bus in the main panel and provides a return path for current. The ground wire is connected to the ground bus in the main panel and provides a path for fault current. Ensure that all 4 wires are properly sized and connected. When running wires through walls or ceilings, protect them from damage by using conduit or cable staples. Conduit provides the best protection, but it is more expensive and time-consuming to install. Cable staples are a more economical option, but they do not provide as much protection. Be careful not to damage the wires when installing cable staples. Ensure that the wires are properly supported and protected. When working with electrical panels, be aware of the arc flash hazard. Arc flash is a dangerous electrical explosion that can occur when working on energized equipment. It can cause serious burns and other injuries. To protect yourself from arc flash, wear appropriate personal protective equipment such as a face shield, arc-rated clothing, and insulated gloves. To energize the equipment whenever possible before working on it. Be aware of the hazards and take precautions to protect yourself. When installing a sub-panel, it is important to properly label all of the circuits. Use a circuit directory to identify each circuit by its function, such as lights, receptacles, or appliances. This will make it easier to identify and troubleshoot problems in the future. Update the circuit directory whenever you add or change a circuit. A clear and accurate circuit directory is an essential part of any electrical system. In addition to the tips mentioned above, here are some additional safety precautions to keep in mind when working with electricity. Never work on electrical equipment while standing in water or on a wet surface. Water is a good conductor of electricity and can increase the risk of electric shock. Avoid wearing metal jewelry or watches when working with electricity. Metal can also conduct electricity and increase the risk of electric shock. Use insulated tools whenever possible. Insulated tools are designed to protect you from electric shock. Be aware of your surroundings and avoid distractions. Electricity can be dangerous, so it is important to pay attention and focus on the task at hand. If you are not sure how to do something safely, ask for help from a qualified electrician. It is always better to be safe than sorry. When installing a sub-panel, it is also important to consider the location of the panel. Choose a location that is easily accessible and has adequate ventilation. Avoid installing the panel in a damp or humid location, as this can damage the electrical components. Ensure that the panel is properly mounted and secured to the wall or ceiling. A properly installed sub-panel will provide years of reliable service. When selecting a location for your sub-panel, consider the distance from the main panel. While the answer mentioned a run of over 100 feet, longer runs require careful consideration of voltage drop. Voltage drop occurs when the voltage at the end of a long wire run is lower than the voltage at the source due to the resistance of the wire. Excessive voltage drop can cause appliances to malfunction and can even damage electrical equipment. To minimize voltage drop, use larger gauge wire or run the sub-panel closer to the main panel. The NEC provides guidelines for calculating voltage drop and selecting the appropriate wire size. Remember that local electrical codes may have specific requirements for subpanel installations. It's essential to consult with your local building department or qualified electrician to ensure that your installation meets all applicable codes and regulations. This will help ensure the safety and legality of your electrical system. When you're working with electrical wiring, it's crucial to use the correct type of wire connectors. Wire connectors are used to join two or more wires together and provide a secure, insulated connection. There are several different types of wire connectors available, including wire nuts, crimp connectors, and push-in connectors. Each type of connector has its own advantages and disadvantages, so it's important to choose the right connector for the job. Wire nuts are a common type of connector that are used to join two or more wires together by twisting them together inside a plastic cap. Crimp connectors are used to join two or more wires together by crimping a metal sleeve around the wires. Push-in connectors are a relatively new type of connector that are used to join two or more wires together by simply pushing them into the connector. When choosing a wire connector, consider the wire size, the number of wires being joined, and the environment in which the connector will be used. Use only UL-listed connectors and follow the manufacturer's instructions for installation. A properly installed wire connector will provide a safe and reliable connection. When installing electrical equipment, it's crucial to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide detailed information about the installation process, including the proper wiring methods, torque specifications, and safety precautions. Ignoring the manufacturer's instructions can lead to improper installation, which can cause electrical hazards and equipment damage. Always read and understand the manufacturer's instructions before beginning any electrical work. If you have any questions about the instructions, contact the manufacturer or a qualified electrician for assistance. Following the manufacturer's instructions will help ensure a safe and successful installation. After completing the subpanel installation, it's important to create a detailed wiring diagram. A wiring diagram is a visual representation of the electrical circuit, showing the location of all the wires, connectors, and equipment. A wiring diagram can be useful for troubleshooting problems and making future modifications to the electrical system. Use a computer-aided design, or CAD, program to create a professional-looking wiring diagram. Be sure to label all the wires and components clearly. Keep the wiring diagram in a safe place where it can be easily accessed. A well-prepared wiring diagram is a valuable tool for maintaining your electrical system. Regularly inspect your electrical panel and wiring for any signs of damage or deterioration. Look for cracked or broken wires, loose connections, and corroded components. If you find any problems, have them repaired by a qualified electrician as soon as possible. Neglecting electrical repairs can lead to serious safety hazards. A regular inspection of your electrical system will help prevent problems and ensure its safe and reliable operation. If you're planning to add new circuits to your sub-panel, it's important to calculate the load requirements for the new circuits. The load is the amount of electrical power that the circuit will be expected to draw. To calculate the load, add up the wattage of all the devices that will be connected to the circuit. The NEC provides guidelines for calculating the load for different types of circuits. Be sure to factor in any future load increases. If the load exceeds the capacity of the sub-panel, you may need to upgrade the panel to a larger size. Overloading a sub-panel can cause it to overheat and trip the circuit breakers. A properly sized sub-panel will provide adequate power for all your electrical needs. Proper planning and execution are paramount for safe and efficient 100 amp sub-panel installation, particularly when dealing with challenging wiring paths exceeding 100 feet and involving multiple 90-degree bends. Adhering to the NEC guidelines, utilizing appropriate materials like Conduit and THHN wires, and prioritizing safety measures throughout the process are crucial. Always consult with a qualified electrician if you lack experience or have any doubts about the installation procedure. By following these recommendations, you can ensure a reliable and secure electrical system for your residential needs.